Hello, today we're going to kind of begin talking about lines and equations of those lines and how you can graph them on a coordinate grid. Our objectives are students will be able to define equations of vertical and horizontal lines, lines in slope-intercept form, and lines given 2 points. Some of the vocabulary you're going to see is system of equations, system of inequalities, inequalities, greater than, less than, shading, dotted or dashed lines, solid lines, and equality. So the first thing we want to really discuss are vertical and horizontal lines. This is something that really bothers students in that vertical lines actually are the x-type lines. And the way I kind of think about this is it's all y values where x equals h. And so, for example, we could have x equal, say, 2. And if you think about where x equals 2, well, it could equal to here. It could equal here, or 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 even in between these places. So like this is 2 and 1.5, and this is 2 and 4, and this is going to be 2 and 6. And what you should notice for every single one of these is that my x value is 2. And so what they do with this is they give you that vertical line where x equals 2. And sort of that's the idea of why this would be a vertical line. And we always label always, so x equals 2 is this line. Similarly speaking, this would be all x values where y equals k. And so your example here might be y equal to -4. And so I'm looking at all the values where y equals -4. Well, here's a value where y equals -4, and here, and here, and here, and here, and here, and over here. Like this one is -3, -4. And this one is 0, -4. And so on. And again, if you connect all of these dots, and they could be in between the dots, and in between those dots, and so on. So we get a line here, and this would be my y equals -4 line. And this is really kind of counterintuitive to many students as they begin to think about, well, why is always the vertical line? Well, we're not really talking about the y-axis in this case or the x-axis in the case. We're talking about y taking on specific values and x taking on specific values. And so vertical lines are the x equals lines, and horizontal lines are the y equals lines. So star this, mark it off, really pay attention to that detail because it really matters. Okay. The next type of line that we're going to look at are lines in slope-intercept form. In slope-intercept form, for so many of us, for so long, has been y equals mx plus b. Remembering that the this is not a slope formula, but this is this line in slope-intercept form. So m is equal to the slope, and the b is equal to the y-intercept. And we're being asked to graph these. And so if you're a problem solver, you may always go through and make a table. So here's the x, here's my y. I put down some values like 1, 2, 3. I fill in. This equation is going to be y equals 2x plus 1. And so I have 2 times 0 plus 1. And I evaluate that, and that's 1. And then 2 times 1 plus 1, that's 3. 2 times 2 plus 1 is 5. 2 times 3 plus 1 is 7. These points come out as 0, 1, 1, 3, 2, 5, and so on. And then I can take these and I plot them 0, 1, 1, 3, and then you can draw the line. Okay, but I'd like to highlight or point out a different way to look at this, and it uses the information. So let's just look at the equation y equals negative 3x plus or minus 2. And let's think about what all those pieces and parts actually mean. Okay. Well, I know that the m is the value in front of the x, or the coefficient, and so for me the m is equal to negative 3. The b value is equal to, it's supposed to be plus a b value, so that must be a negative 2. Now we do need to understand that this is a slope, so it's really best seen as a fraction, because that way we can see our rise over our run. We can use this information to say, well, that's negative 2 on the y-axis. That's what the y-intercept is. And then it's going to go down 3 over 1. Now I don't have any more room, so I can kind of work the other way. It's just got to go left 1 up 3. Left 1 up 3. And so you get a second line. Okay. Now the next question asks, what is the solution to the system of equations from above? And that's the spot where the two intersect. So right there. Now from this graph, it's really, really hard to see. And so I just want to remind you of two methods that you guys have to solve these algebraically. One being substitution, and one being elimination. So substitution would be exactly that. I notice that both y's equal something, but I could replace one y with what it's equal to, so I can say that 2x plus 1 is equal to negative 3x minus 2. If you solve these, I always group, because it's a linear equation, I always group all the x's, so I would add 3x to both sides. I get 5x plus 1 equals negative 2. Subtract the 1, subtract the 1. It's 5x equals negative 3. So x must equal negative 3/5. And like I said, it's kind of tough to see that from the graph, but there's my x value. And every time I do this, I need a y value. So you may take this negative 3/5, pick one of the equations, negative 2 times negative 3, positive 2 times negative 3/5 plus 1. Y is equal to negative 6/5, remembering that we multiply the numerators and then the denominators, that's over 1. And then to be able to add, I need common denominators, so that's 5 over 5, so the y value is negative 1/5. So x pairs up with y equaling negative 1/5. Visually on the graph, that should look pretty much like where it's at. The elimination method is kind of neat in that I don't have these in standard form, but I can still use this. And so with elimination, you just have to make a 0 somewhere. Y minus y. So I'm going to change the signs of each of those. Y minus y would give me a 0 equaling 5x plus 3. Subtract the 3 off, so I get negative 3 equals 5x. And so negative 3/5 is equal to x. Same answer I got the other way. We'd have to go in and figure out y. And y is negative 1/5 from our previous work. And so there you go. So a little reminder on how lines in slope-intercept form work. What does it mean to have a system of equations? It's where the two lines are graphed simultaneously. You look for the spot where they intersect. That'll give you an xy value. You can solve them with substitution or elimination. And so that's kind of really nice. So I would pause it at this moment, the video, and sort of just contemplate and think about what has been prescribed or described so far. Okay. Next, we're going to determine the equation of a line given 2 points with slope, with point slope and slope intercept form. And so when you're looking at this, we're going to kind of embed it in sort of a better problem. Draw the triangular region in the plane. So they're asking me to look at the triangle formed by 0, 0, 1, 3, and 2, 1. And so we're just looking at these very specific lines. Okay, and if there were lines, you'd actually extend them further. So let me do that so that you can see exactly what you're about to calculate. So you have the 3 lines. Each line will intersect one other line exactly once. And then question is, what are the equations? So what are the equations of those lines created by a triangle? And what I have here are a couple different methods. Both require you to calculate slope. And so we've got to kind of dig deep in our memory banks once again and think about what does it mean to have slope. And so reminder, m is equal to y2 minus y1 over x2 minus x1. It's a really good idea to write these down, these formulas, every single time. I'm going to pick 2 of the points, and I'll show you one method and then the other. So the first one says point slope formula. And point slope is y minus y1 equals m times x minus x1. And what those stand for are just particular points based on the slope. And so if you're looking at this, first thing I need is slope. So m is equal to the slope would be y2. Let's choose the points 0, 0, and 1, 3. And so my slope would be 3 minus 0 and 1 minus 0, which is 3 over 1. Now if I substitute that back in, I have y minus y1 equals 3 over 1 times x minus x1. Now the y1 and the x1 come from a particular point. And we're lucky in this because we get to pick 0, 0. And so my choice for x1 would be 0 and y1 would be 0 because they're so much easier to work with. And so if we substitute those in, y minus 0 equals 3 times x minus 0, we'll get the equation y equals 3x. And so that's one of our equations, and that's how you use point slope. Okay. The other way is slope intercept. And we know that this is y equals mx plus b. So m is equal to, and let's just pick 0 and 2 comma 1. So this would be 1 minus 0. This would be 2 minus 0. And so my slope is 1/2. If I fill these in, I'll get y equals 1/2 x plus b. Now this one requires a little bit of calculation. So you get to pick. And again, I would probably pick 0, 0 just because of the ease to which I can use that to calculate. So I'm going to pick x equals 0 and y equals 0 because I have one of those points. And so now I get 0 equals 1/2 times 0 plus b. And so b must be equal to 0. And so my equation is going to be y is equal to 1/2 x. You didn't have to do the math out. I kind of did it just to make sure we've seen it. But if we have slope-intercept form and b is my intercept, my y-intercept, which really is the value when x is equal to 0, ding, 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 our point right here, 0, 0 indicates the y-intercept. I could have just substituted directly in, but we wanted to kind of prove or utilize those resources. The last equation of the line that we have to look at is 1, 3, and 2, 1. And so slope m is equal to 1 minus 3, 2 minus 1, which is negative 2 over 1. I'm going to do the point slope formula just because you guys have never really seen it. So I look at this as y minus y1 equals negative 2 over 1 x minus x1. And you can pick either point. You might want to strategically look at it, try and make sure which one feels most comfortable to you. But I might pick x is equal to 2 and y is equal to 1. And so I substitute y minus 1 equals, notice where I put that, negative 2 times x, it's into the x1, so minus 2. So y minus 1 is equal to negative 2x minus and plus 4. And so y is equal to negative 2x plus 5, and that's my third equation. And you can double check all of your work. Here's an intercept of 5, and it goes down 2 over 1, down 2 over 1, down 2 over 1, so check, that one was done right. Y, the intercept is 0, but it goes up 1 over 2, up 1 over 2, up 1 over 2, check, and then 0, and up 3 over 1, up 3 over 1, and so those are nice. So again, I would ask you to pause, double check any of your work, and ask questions if you have any. The final topic that we're going to get into are inequalities, and ultimately all the line stuff that you were looking at will be used underneath the content of inequalities or perpendicular and parallel lines. Let's review inequalities before we get to the graphs. The symbol for greater than, it does go to the larger side, but if we're reading a sentence that says 5 is greater than 2, the 5 would come on the left, the 2 would come on the right, and so the Pac-Man opens up, or the alligator opens up towards the 5. The less than sign opens up to the right. Greater than or equal to, we have this little equality underneath that makes it greater than or equal to, or less than or equal to. Okay. Now when we graph these, when you're on a number line, you just have an open circle for greater than on a number line, but for greater than or equal to or less than or equal to, you'd have them filled in. How that's represented on your lines is you'd have a dashed line, which means there are breaks in between the parts. Same thing with the less than, you have a dashed line or a dotted line. But when you get to the equal to part, it's just like the equality, so you would have a solid line and a solid line. Okay, so putting these things together, sort of in a graph, it would look like this. Now you've seen this one already, so I'm just going to use the slope-intercept form real quick. My y-intercept is 1, so I'm going to put a dot. My slope is 2 over 1, so I'm going to go up 2 over 1, up 2 over 1, and so on. Now, because this is a greater than sign, I know that this is going to be a dashed line. Okay? And so when I get to that, I'm going to literally dash the line. Now, the traditional way of figuring out which way I shade, because that's all the inequalities, I pick a test point. If your line does not go through 0, 0, that's a nice test point to look at. And so what I would do is 0 greater than 2 times 0 plus 1 is 0 greater than 1. That's a false statement. And so I have to see, here's 0, 0. I'm going to shade away from it. So my shading comes this direction, away from 0, 0. Okay? And the reason why you do that is because technically any point over here in the shaded area will work. So you can pick one. Let's just pick negative 1, 1. If I put 1, is it greater than 2 times negative 1 plus 1? Is 1 greater than negative 2 plus 1? 1 is greater than negative 1. True. Okay, so that is something you want to test out. Now for the other one, we'll just do the same thing. It starts at negative 2, goes down 3 over 1. You've seen this, down 3 over 1. And now that point's not a good one to test because it's directly on my line. But as I do this, it's a solid, because of the equality down here, that's a solid line. So when I come over to the right and graph it, you should have arrows indicating that these lines continue. Now if I'm going to pick another test point, 0, 0 actually works nice again because my line does not go through it, so we can test 0, 0. So is 0 greater than or less than or equal to negative 3 times 0 minus 2? 0 is less than or equal to negative 2. That's also false. I like to put that word in there, and so when I'm shading this, I have to shade away from the 0, 0, so here it is. Now it says, what is the solution set? The solution set is where both of these shaded areas intersect. And so my solution set is all of this area. Okay? And so I'd like you to try the next one all on your own. A is y is less than negative 1/2 x plus 3, and the second inequality is y is greater than or equal to 3/4 x minus 2. So pause the video, get your work going, and when you're done, unpause it. And so here's the solution for you if you wanted to see it. And so things to take away from inequalities are a little bit different than equalities. They have the shading aspect of them. They have multiple solutions that'll work. They're symbolized by the shading that occurs. And then we use this big S for solution set to indicate exactly where all of them are. Notice I didn't put my S in this area because it doesn't have both the black and the green. And I didn't put my S down in this area because it doesn't have both the black and the green. Anything along a dotted line is not included into your solution set. Anything along a solid line is. So I would stop the video at this point, summarize what you've learned about lines. It is definitely a review of some algebraic course in your history, and come in ready to continue tomorrow. Thank you.